Let's discuss a question from theory of machine. This is from gear trains. So epicyclic gear train is given. So we will use the table method, and in the table method we first have to this works in two steps. You need to have the arm, the sun gear speeds, the planet gear, and the ring gear. Okay, so let's first assume that the arm is fixed, and then assume that sun has a revolution of, the center is the sun gear, sun has a revolution of x. So here the planet represents any one of the three planetary gears, because all the three will have the same speed and same symmetrical motion. So if the sun rotates by x, and assume that the arm is fixed at a point of time and the sun is revolving in a clockwise direction, the planet will, because the arm is fixed, the centers of the planet is fixed, so planet will also, the center will be same, but they will, because the sun is rotating clockwise, so the planet will rotate anti-clockwise. And so this forms a classical example of two gears with their centers fixed and with their centers fixed and the gears are in mesh. So when sun rotates by x, so how does the planet rotate? Well, for this, the ratio of speeds always varies in inverse ratio of their teeths. So this is something which you should know, because larger gear, a larger dia gear will have the larger number of teeth, because the module has to be maintained. So the larger, the module is basically the ratio of how much portion of the circumference a tooth is occupying. So larger radius gear will have larger number of teeth, but will have lower speed than compared to a smaller gear which is in mesh. So with that, this is an important relation which we'll be using. So when planet rotates by x, so when the sun rotates by x, from this, the planet will rotate x into ts by tp, where ts is the number of tooth on the sun gear and tp is the number of tooth on the planet gear. Now I also put a minus sign just to represent the clockwise and the anti-clockwise. Now positive here represents clockwise, and minus represents anti-clockwise. So because the sun gear rotates clockwise, the planet will be rotating anti-clockwise. Now coming to the ring gear. Now when the planet rotates anti-clockwise, the ring also will rotate anti-clockwise, because the ring has internal number of teeth. And using the same, now applying this relation between planet and the ring, so the speed of the ring will be the speed of the planet, which is nothing but the same thing whatever we get into, so this is speed of the planet into teeth on the planet by teeth on the ring gear. And with the sign will not change, whatever sign is there on the planet, it will not change, because the planet as well as the ring, they revolve in the same direction. Now I assume that I have given a y rotation to arm, and that gets added in this tabular method. So the total revolutions x plus y, so the absolute revolutions we are just visualizing in two ways, one being the arm fixed, and the other step when we give the entire thing is rotated by y. So this is y minus x ts by tp, and this is y minus t. Now tp gets cancelled, so it's ts by ts r. So now let's look at what is given in the question. What is given in the question is that animation A. The ring gear has a RPM of 300, and so let's write down here the ring gear, which is TR. TR is something which we need to find out. And the speed of the R is 300 RPM, and the speed of the arm is 180. So speed of the arm and speed of the ring is given, and number of teeth on the sun gear is given. Okay, so speed of the arm, that is y, is given as 80. Y is given as 180, as well as the arm, okay, the ring here, that is 1 y minus x ts per tr, this is given as 300 and the direction is same. Okay, so y is 180. Okay, and what about the, okay, anything else that is mentioned? The number of teeth, ts, is mentioned. Okay, the fixed gear wheel s, so that means the sun gear is fixed. Okay, so that is another information. The sun gear is fixed, that is x plus y, which is sun gear, so this is 0. Okay, now combining these two, when y is 180, so and x plus y is 0 because the sun gear is fixed, so x will be minus 5, which is minus 180. And now we substitute everything here. Y is 180, minus x is minus 180, ts is given as 80, tr is something which we need to find out. So this is plus 180 into 80 by tr, and the right hand side is 300 minus 180, which is 120. So this gives tr to be 180 into 80 by 120, which is 42s and 43s, and that goes 180 goes 60, so it's basically 120. So the number of teeth on the ring here is 120. So this is a standard table method problem which we do for every, the procedure is same for every epicyclic gear problem. Any epicyclic gear problem you can solve with this method. Thank you.